Modulating a signal spreads it out over a range of frequencies, resulting in the sideband. This is with FM now. Okay. Spreads it out over a range of frequencies, resulting in the sidebands. This is called bandwidth. Okay, all modulated signals have sideband. So there's your bandwidths, and I think we're going to get some. Yeah, amateur television is 6 megahertz, so it's boxed in with yellow. That means it's a test question, possible. Single sideband voice is 2 to 3 kilohertz. So 3 kilohertz, 2 to 3 kilohertz over here. CW is the smallest, remember? 100 to 300 hertz. Not even thousandths of hertz. 1 to 300 hertz. That's just a narrow little tiny beam. It can punch around the world with next to nothing power. You can go up on the mountaintop with a little card that's this big. I didn't bring it. There's a little card. It's a 40-meter QRP 5-watt radio. And you can talk around the world from the mountaintop with it. That, a piece of wire, and a little bitty battery. Single sideband signals have narrower bandwidth than FM signals. Typical sideband voice signal requires 3 kilohertz of bandwidth. The question is on the test. Excessive modulation is overmodulation. Affects adjacent frequencies. So if you've got excessive modulation, it's going to cause distorted speech. So they're going to tell you, hey, you're overdriving, overmodulating. Back away from the microphone, turn your mic gain down, one of those two. There's other things that can cause it. It's unwanted spurious transmitter outputs are produced by it, and it's called splatter. And it may cause your transmission to be distorted on voice peaks. And you'll get told, hey, you're overmodulating or you're overdriving it. It's usually caused by speaking too loudly into the microphone or too closely to it as well, because the closer you get to it, the more it has a tendency to do that. But if you're being told that your audio is low, turn up your mic gain. The easy way, the poor man's mic gain is just move the mic closer. You go, how's that? Hey, it came up. A little closer. Oh, that's too much. Bring it back up. Speak more softly or move the mic away from your mouth, and if the audio is too low, bring it closer. But this is the questions that are on there. It may cause your transmission to be distorted on voice peaks, and it's caused by speaking too loudly into the microphone, so speak more softly or move the mic away from your mouth to prevent excessive modulation.
If I could make a comment between FM and single sideband. On FM, your voice quality may change and the audio will be low, but your signal strength won't change. The signal strength into the repeater will be exactly the same. It's just that people won't hear your voice as well. On single sideband, you're actually changing the output of your transmitter when you talk softly or more loudly. And this is where the danger of overdriving comes in, because people will want to talk louder into the mic to get a stronger signal out.
Oh, questions? What is the relationship between the electric and magnetic fields of an electromagnetic wave?
Delta.
Ooh, somebody owned that. Times 2. Yeah. They are at right angles.
Yeah.
What are the 2 components of a radio wave? Charlie, you guys were listening or you studied?
I'm studying.
Either that or I'm just a really good teacher. I don't think it's that one. What is the velocity of a radio wave traveling through free space in a vacuum, by the way?
Alpha.
Alpha? Speed of light. What is the relationship between wavelength and frequency? Wavelength gets shorter as frequency increases. You are right. Wavelength gets shorter as frequency increases.
Not backing down.
Okay, that's good. That's good. You're confident. It is correct. As the wavelength gets shorter, it's faster and faster, so it's higher frequency. What is the formula for converting frequency to approximate wavelength in meters? Dang it, they all got 300 in them. Wavelength in meters equals 300 divided by the frequency in megahertz. Everybody agree?
Sure.
Sure? All right, it is delta. In addition to frequency, which of the following is used to identify amateur radio bands? Alpha. Good job. Frequency range, or what frequency range is referred to as VHF. Remember all those 3s I told you about? VHF. Are we sure? 30 to 300. Megahertz. Remember that part. 'Cause, gee, look, the other one's kilohertz. Megahertz. What frequency range is referred to as UHF? Oh, gee, I just gave you that one. 300 to 3,000 megahertz. What frequency range is referred to as HF?
Charlie.
3 to 30 megahertz. Now, how do we know it's not 300 to 3,000? Because that's UHF. 30 to 300 is VHF. 300 to 3,000 kilohertz, that's 0.3 to 3 megahertz. Well, we haven't talked about that, have we? So it's Charlie, 3 to 30 megahertz. What is the approximate velocity of a radio wave in free space? We just had that question, so you should get this one right.
Charlie.
It is Bravo.
Per second, 300 million. What is the unit of impedance? Ooh, that's from a few weeks ago. Unit of impedance is the
Delta.
delta. And if you didn't know the answer, you would guess which one.
Delta.
Because most of them are delta. Not delta. If it's asking you what unit it is and you don't know, most of the units are measured in ohms. So that's a good choice if you don't know the answer.
You can also think of impedance as resistance at AC. So your ohm is the measure of resistance, and to impede something is to resist it.
Yes. If you impede a cop, that's called resisting arrest, right? What does the abbreviation RF refer to?
Alpha.
Alpha is correct. Which of the following is a form of amplitude modulation? Amplitude modulation.
Charlie.
Charlie.
What type of modulation is commonly used for VHF packet radio transmission?
Alpha.
No.
Packet radio is alpha.
Oh, I thought that was UHF.
No, it says VHF.
VHF. Bravo.
VHF is Bravo? Oh, no, I heard you, but
On Alpha.
I didn't know if you were changing your mind. FM or PM?
What is PM?
Phase. Phase modulation. Which type of voice mode is often used for long distance weak signal contacts on the VHF and UHF bands? We specifically. Ooh, hey, listen. Did you guys study or did you pick that up this morning?
We got halfway through it.
You got halfway through. So as we get along here, you're going to start missing them.
Yeah.
Okay, which type of modulation is commonly used for VHF and UHF voice repeaters? I got two deltas, and that's correct. What would cause your FM transmission audio to be distorted on voice peaks?
Charlie.
Charlie.
You sure it's not Bravo? Charlie is correct. Which of the following types of signal has the narrowest bandwidth?
Charlie.
We should have like 2 weeks between every class. Charlie, continuous wave or Morse code? How big is it?
150
100 to 300
100 to 300.
hertz. Hertz, not even megahertz. What is a characteristic of single sideband compared to FM?
Charlie.
Narrower bandwidth.
Oh, I gave that one away.
Give this one away now.
Ah! What's the approximate bandwidth of a typical single sideband voice signal? It's written right there. What is the approximate bandwidth of a VHF repeater FM phone signal? VHF FM.
Approximate is
Approximate.
Charlie.
Are you sure?
Yep.
You sure it's not 500 hertz? Less than 500 hertz? Well, you're right. Just asking. If it's less than 500 hertz, it's going to be CW.
Right. Trust me, I missed that question quite a few times.
What is the approximate bandwidth of an AM fast scan TV transmission?
Bravo. Yep. Bravo.
Bravo? Okay. What is the approximate bandwidth required to transmit a CW signal?
This is where I said 150 hertz.
Oh.
Bravo. That's what I said. You need to back out something else.
This 1 to 300 is with approximately 150. It can get wider, but
It's been confusing.
Ah.
Because that one says this, and then the other
Well,
says something else.
So here's the thing, you gotta just memorize their questions and answers sometimes. Because when we get to the batteries one, remember, they want you to say 12 volt, or 10.5 volts, and that's the answer to the question.
Really want
But
12.
you really wanna not go below 12 on lead acid. Okay, which of the following is a disadvantage of FM compared with single sideband? Disadvantage of FM over sideband.
Bravo.
Bravo.
Only one signal can be received at a time. What is the name of the process that changes the phase angle of an RF signal to convey information? If we change the phase angle, what do we got?
Bravo. Bravo.
Phase modulation. What is the name of the process which changes the instantaneous frequency of an RF wave to convey information?
Delta.
Modulation and its frequency. Convolution. What type of modulation varies the instantaneous power level of the RF signal?
Delta.
You're going to be a general, aren't you?
I'm working at it.
Which of the following phone emissions uses the narrowest bandwidth?
Alpha.
You would say alpha? You've been getting them right, so anybody want to go with him? Because he's been doing pretty good. Are you going with him? It is alpha.
One of the questions, didn't it say that's one of the narrowest is the sideband?
Yeah.
Yes. What is the modulation envelope of an AM signal? Envelope is what?
Alpha.
The peak values. That's your key. Radio equipment basics. Any questions on the section we just covered? Okay, the basic radio station, we've seen this again. Transmitter, transmitter, receiver, switch, receiver, the power supply, because you got to have power to both. And you've got the antenna. And the feed line, of course, because you got to get the signal to the antenna somehow. Okay, accessory equipment. All those little toys up there for the Baofeng, we got them for the big radios too. You can get a headset, an external speaker. Is that a handheld mic? Yep, microphone. Ooh, if you really want to get into it, there's your Morse code key. And if you want to spend more money than your YL or your OM will let you, you can buy an amplifier.
But you really don't need an amplifier to use antennas correct.
You don't need an amplifier.
You hook one of those up to your rig.
Yes, yes, your radio's here. This sends out a small amount of power, and this jacks it up to whatever you're allowed.
So they got those in 12 volt systems now.
So this can be driven by DC, which is rare, isn't it, Steve?
So an amplifier isn't necessary when conditions are good.
There you go.
And it also depends on your own limitations at your station. Maybe you're limited in space. You don't have room for a tower and a beam. Maybe you can only put up a vertical. Well, people aren't going to hear you very well with just a vertical. There's times when I do need it, and I'll use it then.
And the power supply to them. There are DC ones, but for the most part, they're 110 or
They're
220.
amplifying RF. Yeah.
But there are DC versions, DC powered amplifiers.
To power, yeah, you've got transistorized amplifiers that run off 12 volts DC, 13.8. They still take up a lot of amperage. You're going to use some big
Batteries.
Then you've got tube amplifiers that run high voltage, and you can run them off 220 or 120 volts.
Yeah, it just depends on the amplifier. I do have an amplifier. I can take my radio and plug 5 watts into it, throw it through the amplifier and get 65 watts out on single sideband. Well, 65 watts is more than my radio will spit out, so that's the reason to have it, and that will get me up further distance on single sideband. And I have the added advantage of my expensive radio is only running 5 watts, which is easier on my radio. Less heat, I can talk a lot more, and as a politician's recovering, I need that. Basic gear. In addition to your radio, the microphone, we're usually with a push-to-talk or PTT switch. Headphones are nice. You don't realize it until you put a set on of nice ones. So they are really awesome. We've even got ones that knock out all the noise behind you, so if the YL's yelling at you or the OM's yelling at you, you don't even hear them. Or the dog's barking or the kids are screaming, it cancels all that out and you're just sitting there oblivious playing on your radio. Depends on your relationship with your YL or your old man, whether you want to take the risks. External speaker, those are nice. Key code, or code key for Morse code if you want to do the Morse code. The push to talk, PTT. Transceiver's push to talk input switches the transceiver from receive to transmit when it's grounded. Fundamental circuits. Here comes a. Nearly all radios are made up of a few fundamental types of circuits. We have oscillators, mixers, multipliers, modulators. I think that's all on the list here. Oh, and amplifiers. Notice there's nothing yellow there. Okay, but those basic circuits combined together make a radio. What would you need an amplifier for in a receiver?
To boost the voice,
To boost what?
the voice signal.
To boost the incoming voice signal off of that's coming in. The amplifier will take and jack up the voltage because you're bringing in billionths of a volt. Okay, and that's not enough to drive anything to process it and spit it out on a speaker. So the amplifier cranks that up. You can also have an amplifier going on the outside, on the going out part, because you want to get the power up to the whatever you've selected. Oscillators, a circuit that generates a signal at a specific frequency, is an oscillator. An oscillator is a filter and an amplifier operating in a feedback loop. It generates a sine wave, station equipment, receiver, transmitter, antenna, power supply. You need all of those to make a station. There should be a feed line in there somewhere, but there's not. The receiver extracts the information intercepted by the receiving antenna and run down the feed line, and you get losses in all of that, and presents it to the user in a usable format. So it brings in the signal off of the feed line, and then it processes it and spits it out either as audio signal or digital, going into your computer that you can either read the text or whatever, the picture that's being sent. The transmitter converts the information being sent into a suitable mode for delivery by RF energy and sends that signal into the antenna system. Kind of obvious, right? You're transmitting, it's going out. You're receiving, it's coming in. The transceiver is a device that combines a receiver and a transmitter. Okay. Antenna. The antenna is fed the RF energy via a feed line. The RF energy then resonates the energy into the environment in a way dependent upon its design and installation. That's how we get the signal out. We design it to send out that RF energy and resonate it into the environment. The power supply is the electrical energy powering the radio station and equipment. It can vary from grid power to batteries, use converters, inverters, and other equipment to provide the needed power. Some of the radios used to plug into the wall, and then they had a converter inside that turned it to DC, and the radio used it. Now, generally, you're plugging in, if you're using grid power, you're plugging into the wall, and you got separate blocks, and then you wire your radio to that. Or you got it all in a little handheld thing right there. Special stations that you'll use, repeaters. Repeaters are automated stations generally located at high elevation locations that receive and then retransmit your signal simultaneously. So it comes in on the antenna, goes into the receiver or into the receiver side of the transmitter and then of the repeater. Then the transmitter side sends it right back out the same feed line and the same antenna. So the signals are passing each other. And we're able to do that without blowing things up because we have these filters in there that allow things to go certain directions.
So the repeater can only do one frequency though?
One frequency
They're
pair.
separated by some frequency distance.
Yeah, so on 2 meters, we have a 600 hertz.
600 kilohertz.
Kilohertz. Yeah, 600 kilohertz separation. So when I tell you that John's peak is 147.100 positive offset, Tona 136.5. 147.100 is what you dial into your radio. The positive offset is shifting 600 kilohertz up, positive, to a higher number. So 147.100 is what's in your radio, but when you key up, it transmits on 147.700, 600 kilohertz higher. And when you let off, you listen on 147. Make sense?
No.
No? Okay, I'm transmitting on this frequency. It is offset a standard amount. And it's, for 2 meters, it's 600 kilohertz. I'm listening on this frequency. The frequency I'm listening on is the one that's that I'm reading on my readout. When I transmit, it shifts up at 600 kilohertz and transmits higher up or lower. It could be 600
So do
kilohertz.
I need to program the upshift?
Yes. Many modern radios will automatically put in the positive and the 600 kilohertz. But you got to tell it it's a repeater and to do that.
So you need to know both numbers then, right?
Nope. You only need to know the standard is 600 kilohertz for 2 meters. It's 5 megahertz for 440. As long as it's a standard offset, you need to know the one frequency, the one you listen on, the output of the repeater. So you're listening to that. That's the repeater's output.
You just need to know if it's positive or negative.
Positive or negative,
Okay.
unless it's a non-standard shift, which can happen. And then you need to know the tone, which we'll cover what the tone is later. A lot of modern ones will automatically put in positive or negative based on the conventions that are used generally. But you could be on a repeater that's opposite to the general convention and have to manually input the offset.
How do you find them?
You get on your smartphone, or you can buy a book, and it's called Repeater Book. Or you go on your computer at repeaterbook.com.
And then they're licensed individually for each repeater?
So the repeater up on John's Peak is my girlfriend's. It runs under her license. And then all the other ones they have, somebody's got a license. You have to have a control operator because it is a station. So she's the control operator. So if I screw up, she's in trouble. The way it's her repeater.
What is the control operator operating then just for everyone to use? Like,
It is automated station.
So you're making sure it's working all the time.
So her responsibility and mine, because I manage it for her, is to make sure that it's functioning properly. It's not just locked on and transmitting. It actually has a timeout timer on it, so I think it's 3 minutes. It transmits for 3 minutes, it'll shut down. And then it'll turn back on, and if it transmits for 3 minutes, it'll shut down. Hopefully somebody would call me and say, hey, but it's always on and being monitored by me if I'm awake and at home, or if I'm in the car, I'm monitoring it. And then with my little number keypad on my microphone, I can turn it off, or I can turn on the tone.
so they're not necessarily a 24/7 thing.
It's 24/7.
They generally are.
It's sitting up on a hill plugged into the wall and automatically just runs.
So
Okay.
is there an actual like ham radio connected to this thing? So
Yeah.
you can also talk to it? It's not just like this powerful antenna to...
It's a transceiver, okay? And when you send a signal, if he's calling me through John's Peak, his radio, so he can be there and I can be here, and we're on John's Peak's repeater. Our radios aren't going between us; they're going all the way up to John's Peak. So I go, "Hey, Brandon," and it goes up to John's Peak, hits the receiver, spits it out on the transmitter, and his radio, because he's listening on 147.100, picks it up. When he keys up, he goes to 147.700, the offset, and it goes back up to the receiver, spits it out on the transmitter, and I hear it on the
Now
output
it's-
frequency.
It's linked to Peak Radio.
No, it is not. So there's all kinds of things that go into it, but they're automatic. They just sit there. As long as they got power and they're functioning, they just keep on spitting it out and repeating your signal. Answer your questions?
Yeah, I got it.
Okay. All right. Repeaters dramatically improve your range, so that little 5 watt, I can sit with that 5 watt Baofeng and the longer antenna there, I can stand out in the parking lot and probably hit King Mountain, which is at mile marker 76 on the I-5 is where you get off the freeway, and we're at mile marker 20, so probably 28, right around here. Then from there, that thing will go all the way to Oklahoma if there's somebody in Oklahoma listening. Dramatically increases your range. Okay, the basic components of a repeater are the same as your station. you have a repeater, a receiver, a transmitter, an antenna, and a power supply. So when I go up to Johns Peak and I open the cabinet, it's got an Astron 35 amp power supply. It's the same power supply I got sitting on my desk at home to power my 991 Alpha radio. And then it's got an old radio, and then there's a tin can that looks like, I don't know, some kind of candy or something came in it. And inside of it is a layer of insulated material and just a card sitting on it, and the cable comes in, and that's the controller. And so it's tied to the radio, and then the radio spits it out to a set of cans, which we'll cover later. Those are the filters, and up the antenna, up the feed line to the antenna, which is sitting on top of the building. We call them cans, they're
Yeah,
filters.
it keeps the receiver from getting blown out by the transmit signal when the transmit comes on.
Yeah, and we've got pictures of them when we get to the specific, we might have them in this section here. Repeaters are transmitting and receiving at the same time, often using the same antenna. So King Mountain has two different antennas and they're a quarter of a mile apart. Makes that station just kick. This requires a very high quality and specialized filter to prevent the I think we're about to get to the picture. To prevent the transmitted signal from overpowering the receiver. And there they are. Those are 2-meter cans. So you've got 6 of them. They operate in pairs. The way it works is it blocks out all but this tiny little bit of the signal coming in, and a tiny little bit of where, not the amount of the signal, but the frequency that it allows through. So this tiny little bit. They're also called cans, so that's what they look like. Repeaters, there you go. You got your transmitter, you got a receiver. This duplexer, that's the cans, is the duplexer. The transmitted signal is going out at the same time the received signal is coming in, and the received signal is sent over to the receiver, and the transmitter is going right up through the same line. So there's electrical, or RF is passing itself. And somehow doesn't screw thing. I don't know how they ever figured this out. Okay, basic station accessories, human interface accessories. Microphones, you gotta have a way to talk to it. Speakers, earphones, computer, Morse code key, TV, camera, etc. Station performance accessories, antenna tuner. That's not really, it's called an antenna tuner, but it's a transmatch. It lies to your radio and says, yes, the feed line and antenna are 50 ohms. Put out all the power you can. They're lying boxes. Yes, are they not? They lie to your radio, but that's okay. We use them. Okay, linear amplifier. So that's the thing that turns your 100 or your 5 watts into 100 watts, or your 100 watts into 1500 watts.
So that's an RF amplifier
Yeah.
that's transmitting your signal just exactly the way it came in. It's going out at a higher amplitude exactly the way
Right.
it came in.
Because it's linear. Antenna rotator. So you got this big beam up there, it's pointing out somewhere, and that's the only place you can talk to. Well, that's no good. So we have these things called rotators, and we can turn them. And we point them at other places, and you'll hear them on the radio. Oh, what's your location? And they'll look up their call sign on the internet, and they'll know what the azimuth is, and they'll turn their antenna to point to them. Or you'll hear them saying, oh, I'm getting off the back end. That's behind the beam. The beam's pointing that way, and they're picking them up from the backside.
Or up on the mountain.
Was that?
Or up on the mountain.
Yeah, there's a guy in Washington that can't hit the repeater in Portland. So he aims his antenna, he's in Washington State, he aims his antenna north at a mountainside, bounces the signal off, it goes back to the south and hits the KGW tower in Portland. And he can get into the peak radio system that way. But if he aims his antenna at Portland, it won't work because of the terrain. Filters used to attenuate or reject or to pass signals with some defined range of frequencies. So filters reject or pass signals. Rejection is called attenuation. They are classified by their response and how they act on signals. Frequency range passed is a pass band. The frequency range attenuated is the stop band. If you've got a pass band that's this wide and you're stopping all of this, you don't hear any of that noise out there. A low pass filter. So all frequencies below the cutoff frequency are passed through. So anything lower is passed. What do you think a high pass filter is? Anything higher. All frequencies above the cutoff frequency are passed. Cutoff frequencies on the test. The frequency at which the output signal power is reduced to 1/2 that of the input signal. 1/2 the power is the cutoff frequency.
And that's a filter?
That's a filter. Band pass filter has an upper and lower cutoff frequency. So it's going to pass everything that is in between the upper and lower. The filter's bandwidth is the area between the upper and lower cutoffs, the half power points. So it's got a cutoff above, anything above it, anything below it doesn't get through, only those frequencies. And you should hopefully find it printed on the side what the pass is. So the band pass filter passes frequencies between the cutoffs and it rejects signals outside of the cutoffs. So you use it to split out everything. Okay, the band stop filter attenuates signals at frequencies that are between its cutoff frequencies. So you've got a band pass, whatever the cutoffs are, that's what gets through, and a band stop is whatever the cutoffs are, that can't get through. So if you got a neighbor with something that's just messing you up at a certain frequency, you put a band stop filter on, and it knocks out that frequency from getting into your system. If the stop band is very narrow, it's called a notch filter. Best signal to noise ratio for single sideband is with a 2,400 hertz filter bandwidth. That's your best signal to noise ratio. So if you select single sideband and you set filter, your radio is probably going to turn on a 2,400 hertz filter. Best signal to noise ratio for single sideband is 2,400 hertz filter. Insertion loss, it's yellow. It's the attenuation of a filter inside its pass band.
So this is the loss of signal created by putting the filter in the line. So when you've got power going out and you put a filter in there to limit extraneous interference, it's going to have some kind of a loss. So that's what we're talking about.
Right. So if you put 100 watts in, you're not going to get 100 watts out on the other side of the filter, even though it's in the pass band. Ultimate rejection is a filter's maximum ability to reject signals outside of its pass band. So it can be, if you're parked next to a commercial broadcast station, your filter may not be tough enough to knock it all out. So that's the ultimate rejection. Maximum ability to reject signals outside of the pass band.